All right, now we're going to look at the rotational inertia for a system of particles. Now, when you have a system of particles, you're going to have them attached together by a massless rod. We need the massless rod because it becomes a rigid body if the rod has mass. So this object is going to rotate about its center, and both masses will be a distance of r away from the center. Now, we have our equation for I, and that came about from the kinetic energy equation. All right, so that I is equal to the sum of all the masses times the distance they are away from its rotational point squared. So we have two particles, they're the same mass, so I have to sum up two particles. So I is equal to the mass of 1 times the distance of 1 squared plus the mass of 2 times the distance of 2 squared. And it's a pretty straightforward addition. You have 2mr squared. Pretty simple. You take that same type of object but change the point at which it is rotating. We're going to try to even it up there. Again, massless rod, but let's just change the point at which it's going to rotate. So let's make that there. So this will be r over 2, and make this just r. Still have the same mass. So starting with our equation, out of both masses, so we have m times r over 2 squared. So r squared over 4 plus mr squared. Now we have to figure out how to get those combined. 4 over 4 plus 1 over 4 gives us 5 over 4 mr squared. So just by changing the point of rotation, it has changed the value for our rotational inertia. Now what the rotational inertia kind of is its resistance to starting rotation or stopping rotation. It's the same thing as linear inertia. An object will try to maintain its current state of motion, whether it's moving or not. So this object would be easier to start to rotate than this object. Now if you change the mass, you just have to alter the mass value. So if this was 2m, then this one would have to be 2m. And that would just change the total, since this would be 8 over 4, which then makes that more difficult to rotate. The more mass farther away from its rotation point. If you have more than 2 particles, you just keep going. And what gets messed up most often is forgetting to square the total radius, especially if it's given as a fraction. So you'll get some practice with this. Let's look at what happens if it's not a particle and it's just a rigid body.